this question, we are asked to simplify a long Boolean expression using the K-map method. The first thing we're going to notice in this problem is that it is not in sum of products form. So I can't really tell how many variables are inside this Boolean expression, how many variables are in each term. So I'm going to start by distributing this inverted C across to the other two terms, which will give me the sum of product format. So I will multiply the factor C inverted by the factor A inverted, B inverted, C inverted, and that'll give me, oh, in the question, this is supposed to be a D actually, and that'll give me A inverted, B inverted, C inverted, D inverted, and another term, which will be C inverted D and D, or the rest goes along for the ride, A and B inverted and C, and the last term is D. So I look at this and I see 1, 2, 3, 4 factors in this term. So now I know that this is a 4 variable K-map. So because of that, I must have 2 times 2 times 2 again. I must have a 4 by 4 matrix in order to account for all of the spots, for all of the combinations of variables A, B, C, and D, whether they're inverted or not. So this is the premise of how big my map is going to be. It's 4 variables. So I'm going to have 8 plus 8, 16 different combinations of these 4 variables. Now, in order to make this map, I'm going to represent these variables along the x-axis and the y-axis. And if we remember, this is actually really a cube that's all sort of compressed out, but we'll represent 2 of the variables at a time as we go through this flattened cube per se. We have to make sure that we follow grayscale rules, which means change one thing at a time. It doesn't matter what you start with up here. It doesn't matter if you if you start with your variables inverted or not inverted. It just matters that you change one thing at a time. So I'll do variables A, B down the side, and I'll do variables C, D across the top. Again, it doesn't matter. I could have done A, D down the side. I could have done C, D down the side. It doesn't matter, but let me choose to fill these in like this. So I'm going to have the inverted of all of the variables in the corner. I could have chosen to have the uninverted in the corner. It could be any combination you want. It's just that grayscale, the grayscale method says, if I'm going to my next variable, this C can change or this D can change, but not both. So let's just keep the C inverted. Then I can change the D to uninverted. And then when I go over to the next one, let's keep D the same. If I keep D the same, then I can change C to be uninverted. All right, so I've changed C. Now, when I hop to the next one, if I change D to inverted again here, and I leave C the same, that's the missing combination, because I have to make sure that across here, I have every combination of a variable C, a variable D, inverted or not inverted. And there's 4 different combinations for those 2 variables in two states. Same thing along here. And some people like to represent it like this: 0, 0, 0, 1, 1, 1, 1, 0. They like to look at the grayscale that way, where the zeros represent inverted variables. So if we looked at it that way, then we would have our AB, 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 this one's inverted, and this one's inverted. So when I moved from here to here, I only changed the B variable. When I move from here to here, I only change the A variable. When I move from here to here, I only change the B variable again. And now I have all of the combinations that exist on inside this Boolean expression that I want to simplify. Let's look at getting the little ones into our Karnaugh map. So now I look at this Boolean expression and I say, okay, I'm going to fill in the square where there is a inverted A, inverted B, inverted C, inverted D. So here's inverted A, but I have to have inverted A and inverted B. So I am definitely going to be in this row. I need inverted C, inverted D. So inverted C, inverted D exists right here and only right here. So I would put a 1 right here for the first term in this Boolean expression. For the next term in the Boolean expression, I am going to take all of the squares that have inverted C and D. So inverted C happens here, inverted C happens here, and it has to have D not inverted, so it's actually just this column here, and everything else can be whatever it wants to be in terms of variables A and B. So I'm going to take that whole row. In general, if you see only 2 variables here, it means that the other 2, it's going to be all combinations of the other 2 variables that have come out of that term. Similarly, we're going to expect to fill in a line if we look at this next term. Here we have A that is not inverted, which happens here and here. B has to be inverted, which only happens down here now. And C is all combinations that they are not inverted. So that would be here and here. There we go. And let's look at the last one. It's only a D, so that one's probably going to get pretty big. It's only a D. Let's do that one in orange. The last term is only a D. Then the D is not inverted, so that would be this column and this column. Oh, the D is supposed to be inverted. Sorry, I transcribed it down wrong here. The D is supposed to be inverted, so it is not those 2 columns. Let me see. It is going to be only the inverted columns. It's going to be this column, and it's going to be this column. Oops, not this column. It'll be this column where D is inverted. So it'll be this one that's already here, and another one, and another one, and another one, because this D doesn't care about the state of A, B, and it doesn't care about the state of C either. There we go. But it cares that it's D inverted. There we go. It's taking the C's and the C inverted. So here we have our K map. And from here, our next steps are going to be to group. So when we group, let's just write our next steps are going to be to group. We have to group some lonesome ones. I don't have any lonesome ones. All the ones I see have neighbors. Even this one has some neighbors, has a neighbor here, has a neighbor there. Then we need to group 8s, 4s, 2s. We're not allowed to group 5s or 1s. I mean 5s or 3s. Let's look for a group of 8. Do I have a group of 8 1s? Yes, I do. I think I have a couple of groups of 8 1s. Here I go with a clear group of 8 1s here. Yes, there's a group of 8 1s. Do I have another group of 8 1s? I have a few rules here. First, there's the lonesome ones. Then there's these groups of 8s, 4s, and 2s. And then I have to give myself 2 reminders here. I have to remember that we can overlap. So if I give myself the freedom to overlap, do we have more groups? Yes. And we can reach around, because remember, this is actually a big cube that has been flattened out. So if I overlap, I can say, all right, I've got these ones down here. I can overlap them and grab these other two ones. That's a group of 4, and a group of 4 makes me very happy. And then I see a group of 4 over here all by themselves, but I have to remember I can overlap. Yep, here I go overlapping, but I can also reach around to the other side. So if I were to reach around, remembering that this is a cube that's flattened, I could actually make another group of 8. This is the same as cutting. If I were to cut this here, then I would have 1, 1, 1, 1, 1, 1, 1, 1. And if I took all of this and put it on this side, then it would look like this, wouldn't it? It would have this 1, 1, 1, 1. And then that's the same. Now I'm circling here and here would be the same as circling them here, wouldn't it? And then circling your other group of 8 here. So it doesn't matter how I made that map, right? I could have made it with CD, C, D prime, C prime, D prime, C prime, D. I could have made it like that. That would be equally as accurate. When I made it like this, I had to wrap around to the other side to find that group of 8. If I would have made it like this, it would have just been 2 groups of 8 overlapping, and I wouldn't have to uncomfortably reach around to that other side. But that's why we can do that. And I'll just tidy this up a little bit. Okay, so I have reminded myself that we can reach around to the other side. I had reminded myself that we can overlap, and I got myself 2 groups of 8 and 1 group of 4. I think that's a pretty successful grouping. So our next step then in the K-map method is I want to look at all of these groupings, and I want to remind myself that the union of all of those variables simplifies to the union of these variables simplifies to whatever is common in those variables. And what I see that is common in there is really this row. It is A, B inverted is common here. And now if I look at this other group here, this group that is in navy blue here, the unions that are common here are really, there's A's and A primes, there's B's, there's B primes, so that's not common. There's D's primes, but I see that every one of these has a C prime, a C inverted, so that's what's common there. And then this union represents what's common as well. This union of 8. What's common is, well, C prime is not common. D prime is common. So D prime is common. A prime, those are not common. B prime is not common. So these are the factors that are common in each of those groups. So we can now conclude, therefore, the simplification or the simplified expression. The long expression is up here, but the simplified expression is y equals A, B inverted plus C inverted plus D inverted. And that's our final answer. So instead of doing step by step of Boolean simplification with the algebra, we can map out this K-map, and then simply the answer sort of jumps out at us, since the union of all of those variables simplify to these simplified terms.